Well, hello friends. Welcome back to the program. Today I was reading this article about system call origin verification in OpenBSD, and I think it makes sense, and it's something that we should do in Serenity OS as well. So the basic idea here is that during normal operation, system calls should really only happen in libc, and in the dynamic loader, and on signal trampolines. And any system call coming from elsewhere, like from another library or from the main program executable, would be an error. At least in Serenity it would, because really only libc should be making syscalls. And we probably do have syscalls outside of libc, but we can easily move them all into libc. So the idea here is to make it an error and crash any program that does a syscall outside of libc. And it's part mitigation against ROP attacks, but it also feels like generally a good sanity check to have. And because we control everything, we can easily move all the system calls to one place and just make it an error to call the kernel elsewhere. So yeah, so today we're just going to implement this system here in Serenity and see how that goes. So I think this is primarily going to be for dynamically linked programs, at least at first. So obviously for a statically linked program, everything is in one chunk, so we can't really say this chunk here is libc and this other chunk here is something else, because it's, you know, static. So we're primarily going to focus on dynamically linked programs. And my understanding is that in OpenBSD they solve this with an Syscall thing, which you call the kernel, and you can only call this once, and then it informs the kernel about which region contains libc. So this is really for the dynamic loader to call after it has loaded libc and it's ready to run. So I think we can do the same thing here. So basically have an syscall, and if this is ever called, then from that point on, syscalls may only happen from the region specified to syscall, and you can't call syscall again. So let's start by implementing syscall. Okay. And we'll put him next to mmap and friends, I guess. Syscall. Yeah. Okay. And then we want to find a region that corresponds to this range here. So region from range, base and size. Is that how we normally do that? Find region from range. Yeah. Okay. Okay. So if we don't find a region, then what errors did they have? Enval, specified address range would wrap around. All right. Well, if we don't find it, that's also enval maybe? I don't know. Let's see. So if you've called syscall before, that's also an error. Attempt to call syscall after it's already been called, right? Eperm. Return eperm. Okay, and then all we need to do now is just say set can make set something like that is syscall region. Yeah, that works. Is syscall region. Okay, so let's add the has called msyscall member to process. Okay. And region gets a bool is syscall region, which of course will be false by default. Syscall region. Yeah, I guess that's okay. Set. I was thinking if we should call it something else, like syscalls allowed or something like that. Allow syscall. That works too. Okay. Although, if you never call this, then all regions allow syscalls. So maybe we'll do this instead. Yeah. Okay. And then m has syscall, or has called msyscall. Okay, and we will also expose this. Has called msyscall, or has syscall regions. Maybe that's a better name. I'm sweating the names here, but I want this to be understandable when browsing around in the code. So I think we'll go with that name. Has syscall regions. And then you can have multiple, and that's okay. Maybe we'll even call it enforces. Okay. Good, good, good. So now you've called msyscall, and I guess we're going to call this in the dynamic loader right before we call the main function of the loaded executable. So in dynamic loader main, we call linker main, and after we have loaded all the shared libraries and stuff, then we'll call the main function, which is the entry point of the executable. So I guess that's gonna be, wait, isn't that just gonna be start? I think that would be like underscore start in libc, probably. Anyway, whatever we call, before we call it right here, this is the where the dynamic loader calls into the loaded program. Before we do that, let's make a syscall. So sc msyscall, and then we need to give it the base and size of libc, which of course we have somewhere. So we would need the dynamic linker class to keep track of that somewhere. Mlibc text base, mlibc text size. Okay. Actually, let's see. And how do we keep track of these? I guess when we are loading, see, map library, map dependencies. So when we map libc, or when we load libc actually, load elf, loader link. Okay, so this is kind of a lot of stuff going on here, but okay, so in dynamic loader load program headers, when we load libc, then we'll want to keep track of where we loaded it. So we need to, can we find out the name of what we just loaded here? Dynamic loader, do we know his name? We probably do. If name is, okay, I don't know what what the format of these names are, so let's print them out so we know what we're looking for. But essentially, when we're mapping libc into the new process address space, then we're just gonna make a note of where we put it. Dynamic linker. So I think we'll do something like wait, where do we store all these things anyway? Loaders. This guy keeps track of all of it. Commit elf. Initialize libc. Oh, wait a minute. We're doing something with libc here already. So initialize libc, we could totally memorize that here. So object base address. Oh, now we're talking. What else can we find out from this object? Base address. So the base address is cool, but we also want the text segment size. Or I guess, you know what? I guess it's fine to just, we can just use the base address and then we can teach the kernel to just take whatever region that the address is in. That's the region that we'll use, so we don't need to know the size. Libc base address is object base address. And then we can put that here, so like static virtual address, boom. As putter, okay. And then we can use find region containing range. And then we'll find, even though we only specify 1 byte of libc, that's enough to find it. Okay. So what do we want to say about this? So like region named is now a syscall region, let's say. All right, so this is looking very promising, right? Like region named libc.so, text is now a syscall region. So it's definitely picking the right region. And then when it comes to enforcement, what we want to do is in the syscall entry point in the kernel, So in Syscall handler, we already grab the region that's calling us to verify to do some sanity checks, like the fact that the region you're calling the kernel from exists, or that we know about it, that it's not writable for whatever reason, and if calling region is a syscall region. So we should check that. But first we need to check if the process enforces syscall regions, and it's not one. Syscall from non-syscall region. And then we'll crash because of that. That's kind of cool. We'll crash you with a segv. Yeah. Okay, so let's try that. And then we just need the I think this will be good. So file manager crashes? Sure. I wonder why. File manager crashes. Syscall from non-syscall region? Sure. And can you tell us where? It's in libpthread. Oh, I see. Okay, so libpthread is not allowed to make syscalls anymore. Huh. Oh. I guess we should probably allow libpthread. So libpthread and libc. You could say that like libpthread and libc are kind of part of the same package. Should we make libpthread call libc for simplicity? No, I think it's okay if we allow libpthread as well. So maybe an easier way to approach this is when we encounter the fact that we're linking in the pthread, then we'll make msyscall then, but we can only call msyscall once. Should we have an interface where you can call msyscall multiple times and sort of like unveil? And then when you call it with null as the argument, then it gets locked and you can't call it again? That makes sense to me. We can approach it that way instead. Okay, so let's see, if name is one of libc.so or libpthread.so. Okay, and then we'll just do it this way. Yes. Okay. So we're kind of straying away from the OpenBSD msyscall style, but in spirit, it's about the same thing. We're just approaching it differently. And yeah, so we'll set enforces if you call it with a null address. If not, address true. We're all good. Yes. Okay, okay. So then we just call Syscall whenever we encounter some library that we want to allow to make syscalls. And when we're finally ready to launch the executable, then we call Syscall with null putter. That makes a lot of sense to me. Okay, so system server now fails. File manager desktop also fails. Sure. So I guess now we're going to find all the places where we're doing this kind of stuff that we're not supposed to. We still have file manager desktop doing this. What's it trying to do though? Read link. Oh, libcore is making a syscall directly? Yes, it is. And see, now we can actually stop doing stuff like this. So I guess we're gonna have to make a wrapper and we'll put it in libc. So the syscall read link is a little different from libc read link, so I think maybe we'll make a syscall or a libc wrapper and we'll call it like Serenity read link. This is a bit annoying, but this is what we wanted. So Serenity read link. So we have a path, a buffer, okay. And buffer size d, buffer size, something like that. Let's update the copyright, because why not? Okay. And finally, we can make the system call here. So instead of this, it will simply be Serenity read link. Link path. Oh, that's annoying. Okay, path length, I guess. I mean, it's not annoying that you're specifying how long the string is. That's a good thing. Okay, if that fails, then return, or wait, what do we return? Like that, okay. And then we call read link with a larger buffer. Sure. So well, this is a good thing to fix this up. Okay, so I think we have successfully moved the read link thing into libc. Wait, why can't I? Oh, I can't include this on the host build, of course. So this will make some like nice little refactorings happen here. We can commit them separately, of course, because it is kind of gross that we were doing system calls directly in libcore like that. Okay, so nobody crashed on startup. That's great. Desktop shows up. Everything's good. Oh, so we have a crash in system server. Syscall from non-Syscall region, bruh. Oh, I bet that's in the signal trampoline. We gotta fix that. So we need to, when we map the signal trampoline in the process, we need to say that it's we need to say that it's a Syscall region. So where do we map it? Return to ring 3 from signal trampoline, blah, blah, blah. Trampoline region. Okay, so when we create that region, we'll just say that it's a Syscall region. Yeah. And then resizing should be allowed. Yeah, that's great. Crash works. System monitor. Things are good. Browser totally works. You can even go to the web. Okay. Yeah, so basically now in all programs that we run, they will only be allowed to make syscalls from libc and libpthread. That's really awesome. And yeah, so we start enforcing it once we leave the dynamic loader. There's probably ways to tighten this further, but I think this is already pretty nice. So we should probably expose this somehow in pmap, for example, and in the system monitor. So obviously if I do this, I can't really see. We could add a new access bit here. Like we have S for shared. We could have a large S for syscalls. So let's see about that. First, let's actually expose the bit. So we have shared, syscall. Yeah. And then in pmap, we will add this little bit here. Syscall and doof. And let's just do it with these. Cool. Okay, so we can see that libc has a syscall bit set and libpthread. But everybody else, no syscall bit. And we can't actually see the signal trampoline page here because it is a special page mapped by the kernel. So user-space programs can't see where it is. It's not really hiding anything important. It's just the architecture doesn't allow us to expose it right now. But this is pretty neat. So let's see if readlink still works, by the way. So if I click on this, which is a symlink to my home, totally works. Symlink to help, totally opens. Very, very cool. Okay. Bloop. Okay, I like this quite a lot. So let's commit the libc stuff first, just exposing the read link thingy. Serenity.h. So serenity.h is a libc header we have with like various Serenity specific system calls. So stuff that's not like standard Unix things, but sort of like UniSTD, but our own inventions. So we have like anonymous files, a way to get the bounds of the current program stack, interfaces to the user space emulator, a little bit of this and that. So this kind of fits there as well. Libc add libc wrapper for the read link. Since this doesn't, yeah, well, to avoid having to make direct syscalls in libcore, let's add a wrapper for the kernel's read link syscall in libc. Okay. And then here in libcore file, or use Serenity read link instead of making syscalls directly. Cool. And then I almost feel like we should call it something other than msyscall, but well, the name is pretty cool, so I think we can get away with it. So okay, so let's add the kernel stuff first. And I think we also need to care about what happens when we fork an exec. So on fork, obviously we should copy this state. Enforces syscall regions is enforces syscall regions, and when we clone a region, we need to clone that state as well. So region if region is syscall region, set syscall region. Yeah. There we go. And when we split the region, can't forget about that one. Otherwise, I'm going to walk into the same bug that we had a while ago, where the munmap splitting bug, where you could create new regions that were private from a source that was shared. If source region is Syscall region, then regions at Syscall region. Yeah. Actually, this API is kind of dumb. Maybe we should just make it take a bool, because then we can do this. That's a bit nicer. Yeah, let's do that. And then we don't have to do ifs, but instead we can simply pass this along like that. Boom. And oops. Boom. Okay, that's pretty good. And I guess when we exec, then we need to clear the state so that we don't start a new process enforcing these. So in do exec, wait, what even happens with that? So like you would start a new process and it's immediately enforcing these, but no regions in the new process will have those bits? Wait, why does that even work? Maybe it doesn't. Oh, wait. I guess now that it propagates across fork, then everything falls apart because we need to clear it on exec. So forces Syscall regions false. Yeah. So this is like, you know, like pledge and unveil. This is sort of opt-in mitigation. So if you can like supply your own code and like compile a binary for Serenity, it's not gonna protect you from making syscalls, right? But this is more about protecting the programs that we already have that are running. So for example, like the browser, right? Like if I go to a web page and that web page compromises the browser, if the exploit wants to make system calls, it now has to locate libc or libpthread in the ASLR address space and I guess use like ROP to leverage the existing syscall sites. So it can't just find a random interrupt instruction and use that. It makes sense to me to it's like defense in depth, right? Like it doesn't cost us anything really, and it enforces correctness and that's always good. So this looks cool here, and in the extended format, which is very large with these fonts. Let's shrink that a bit. Cool. Yeah, very nifty. So let's see. Allow add msyscall for opting or specifying which regions may syscall. Specifying regions that may syscall. add a way to specify which memory regions can make syscalls. Yeah. This patch adds syscall, which is loosely based on an OpenBSD mechanism for preventing syscalls from non-blessed memory regions. Dynamic loader. Well, we don't use this yet, actually. So it works similarly to pledge and unveil. You can call it as many times as you like. But after, but it stops, and when you're finished, call it with a null pointer, and it will stop accepting new regions from then on. If a syscall later happens and doesn't originate from one of the previously blessed regions, the kernel will simply crash the process. Yes, that's cool. And then pmap, show syscall regions with S. Okay, and libc base address, we don't need that thing. Libelf. So mark libc.so and libpthread.so as syscall regions. Also, before calling the main program entry function, inform the kernel that no more syscall regions can be registered. This effectively bans syscalls from everywhere except libc and libpthread. Pretty neat. That is pretty neat. So we'll see how this goes, but I have a good feeling about it. So I'm sure we have syscalls elsewhere, like the user space emulator very aggressively makes system calls, for example. So we probably need a story for that. Instruction H867, wait, what? Okay, well, it seems like the user space emulator is a bit more broken than I knew about, so I need to investigate that separately. But even so, like for the user space emulator, we need to do something about all of these syscalls. So one option would be to have some sort of special thing where when we launch the user space emulator, then we bless the text segment of it so that it can make these system calls. Let's see, who else makes system calls? So libkeyboard. Oh, it's really only libkeyboard. Okay. And we can totally move these out of libkeyboard and into wrappers. That's not tricky. So I'll put that exercise outside of the video, but for user space emulator, that's interesting. So I wonder what's up with these assertions here. I know they were added recently, and maybe that's, I mean, that's not a bad thing because we should probably assert there, but I don't know why we're asserting. Presumably we're trying to decode some instruction that we don't understand. Or wait. What if we don't have any immediate bytes in the instruction? Oh, this is not even correct. So it's fine. The default is just to fall through for 0. Oh, so this was just somebody adding these assertions and me not thinking about what I was approving. Yeah, because if an instruction doesn't have immediate bytes, then we shouldn't assert, because many instructions don't have immediate bytes. That's fine. If anything, we should assert that the immediate byte count is 0. Okay, so now we got a different segmentation violation. Sure. And what is it? It's that we're making a syscall from a non-syscall region. So that's better. So let's fix these assertions to at least make sense. Assert m2 bytes 0. Yeah. Otherwise that just, yeah, that doesn't work. And then I wonder what, I guess we can make an exception in the dynamic loader for UE. So right where we did libp thread SO, we can do something like user space emulator. So we just bless it. It's a bit weird, but maybe that works. So what are these called? And now I need to see the name again here. Maybe it has like the full path. Probably has the full path, like bin user space emulator. Yeah. Okay, well we can check for that. So that's a little bit of an interesting hack here. So we'll make an exception for bin user space emulator. I think that's fine. Now we're starting on emulator CPP 972. Oh, we don't support partial M on map in user space emulator. Well, that's going to take a while to fix. So I'm not going to do that in the video. I think we'll just add the exception for UE here so that we can at least run it. And we'll also commit these fixes to libx86. Don't assert just because an instruction has no immediates. It's perfectly fine to not have immediate bytes. Many instructions don't. Yeah. Actually, should we make an exception for the keyboard thing as well? libkeyboard.so, because I guess now if we try to launch the keyboard settings app, we could just make an exception for it and then Wait, that just works? Keyboard mapper crashes. Okay. It crashes in libkeyboard.so. Right, so let's make exceptions for these two things, and then it can be like a to-do item to scale back the exceptions and get rid of them. So libkeyboard.so. Yeah, so this one is pretty easy to fix, but let's at least keep things in a working state. Yeah, so you see now we have the exception and it just starts. So I change my layout to finish, and I'm totally typing on a finish layout, which is super weird because it's the same as Swedish, but it's super weird to me because I never use it. Okay. I guess that's sort of everything. Add syscall region exceptions, or make syscall region exceptions for UE and libkeyboard.so. These two are currently making some syscalls, so we'll have to make exceptions for them until we can clean them up. Yeah. Okay. Oh, and let's also expose this in System Monitor in the memory map widget. So shared is S already, capital S. Interesting. So what, C for syscall? And we should probably fix pmap as well. We'll put C for syscall. Okay, so let's look at File Manager Desktop. And access is right here, and we scroll down, and here's a C one right here, libpthread. Cool, 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 cool. And the C is for syscall, although now it doesn't need to be capital C here anymore, so. Okay. And let's turn this into a fix-up. So let's put that here, a fix-up, and reword. Yeah. I think that's basically everything that I wanted to do today. So what have we achieved here? We have successfully made a system where you can no longer make system calls from arbitrary places. It has to come from libc, libpthread, libkeyboard, or userspace emulator. As long as you opt into this mechanism, right? But in practice, all of our programs will opt into this mechanism. And stuff like GCC or whatever keeps working just fine. So that's good. Yeah. So this would only break something that uses system calls directly, which we don't care about. Okay. Yeah, I guess I'm pretty happy with this. This is neat. I was just thinking, is there something more I want to do in this area? There's probably something more we could do with this, but I'm kind of drawing a little bit of a blank where to go with it. So maybe we're done for today. So I hope that you saw something interesting here. I thought this was pretty neat. And I'm happy that this story came up today. I read about it on Hacker News, I think, because it was kind of interesting. It's an interesting concept. So now we have it. It doesn't work exactly like OpenBSD, but it achieves the same thing. So cool. If you made it this far, then I thank you for watching and for hanging out. I hope that you learned something, and I hope to see you next time. Bye.